So welcome. Today Academic Daddy will be teaching you everything about differentiation. Now, in this differentiation class, if you're watching this video, know that I'll be teaching you product rule. But before product rule, I'll be teaching you the most dynamic which you must make use of, which is what we call the power rule. So this is the first one I'll teach you today. So if you're watching this video, do well to go and check out the product rule, the quotient rule. This is also called L'Hopital rule. Now, do well to check the implicit method, which we call implicit rule. Do well to check out the chain rule. Then, I'll also be teaching you solving using U substitution. Alright, now that you're there, let's start with power rule. The first one, which is the one I'll be teaching you today, power rule. So I'll be teaching you everything calculus, and this is mainly second semester course for so many schools, while some do it first semester. Power rule. Now under this power rule, you need to know that for any variable, say x raised to power n, power rule said that you should know that for any power of a variable, that variable should be turned to the coefficients, then the power should be turned to the coefficients, and then the power subtract 1 from it. So that this is the n, the power. So that if I have, for example, x raised to power 2, x raised to power 2, that I should get this to become the coefficient, the 2. Then I subtract 1 from the power, so that this becomes 2x. This is what the rule is talking about. And you need to know that if this is x raised to power n, that there's something called f of x. F of x is the same thing as y. Now, f prime x is what we call d of the x. And this is the same thing as saying slope. The part that can get you the slope. And the slope we're talking about here is not just any type of slope. This is what we call secant slope. Secant slope, where it meets 2 points. And this is the one you normally do in your physics, where you say y2 minus y1 all over x2 minus x1. This is it. It's different from tangent slope, where we have a circle meeting this at a point. It's different from tan slope. So, but we'll teach you this as we progress. So if you know this now, let's start. Let's say I have, for example, exercise 1, 2x squared plus 3x plus 2. I have the f of x to be this at x equals to 2. At x, f of x to be this at x equals to 2. All you simply need to know is that if this is the case, using the power rule, I'll have that there is 2 here already. There's something called constant multiplication. So that constant d dx. So that I now have the 2 here, bring it down. I already have this 2x, right? It's differentiate this. So that I now have the 2x I have here. Then the power, then 2 minus 1 from the power. So that I now have this times this becomes 4x. Then this is 1. And anything raised to power 1 is that thing. Plus, I have an invisible 1 here. Times this becomes 3x. Then this is 1 here. 1 minus 1. Minus 1 from the power. This is the same thing as plus 3x raised to power 0. And anything raised to power 0 is 1. So this is 3 times 1, which is the same thing as 3. Now, the derivative of a constant, just note it. Anytime you see a number, the derivative is just 0. So it's nothing. So our final answer is this, 4x plus 3. But look at the question. The question said at x equals to 2. That means that the f of x, when x is 2, as x is 2, is the same thing as 4 into 2 plus 3. So that this is now the same thing as 8 plus 3. And if you check it, this is the same thing as 11. This is our answer. So if you know this, I want to give you one to solve for me. So I have examples here. F of x equals to 1 over x squared. F of x 1 over root x, 2 over root x squared. Then 6 over x cubed dot x half. Now let's start from the first one. This is simply the same thing as, since you know this is f of x, f prime x will be equals to, remember that in this is said that if you have 1 over x squared, it's the same thing as x raised to power minus 1. So if you have 1 over x, it's the same thing as x raised to power minus 1. So if you have 1 over x2, it's the same thing as x raised to power minus 2. If you have 1 over x3, it's the same thing as x raised to power minus 3. So that's what in this is said. So this is the same thing as x raised to power minus 2. You must change it from this to this before you can be able to get the derivative. So the f of x is still the same thing. Now f prime x is going to be the same thing as saying, carry this, put as the coefficient, then write your x minus 2. Subtract 1 from the power. That is becomes minus 2x minus 2 minus 3 is the same thing as minus 3. Now see that it's still carrying minus. So this is the same thing as, know that this is the same thing as minus 2 times 1 over x raised to power 3. Using this. And this is the same thing as minus 2 all over x raised to power 3. This is your final answer. Now let's move to the second one. They said f of x is equals to 1 over root x. Are you aware that this is the same thing as 1 over x raised to power 1 over 2 indices? So if you know this, you know that since it's having positive power here, when it crosses equality sign, this is the same thing as x. Sorry, when it comes up, it's the same thing as x minus 1 over 2. So if you know this, the rule, power rule, carry this thing that I have here and put as the coefficient. So that this becomes minus 1 over 2, then x minus the power, subtract 1 from the power. So that this becomes minus 1 over 2, then x, let's do it. 1 is the same thing as 2 over 2 or whatever, but let's do it the way you understand. 1 is the same thing as 1 over 1. So this is the same thing as minus 1 over 2 minus 1 over 1. LCM is 2. 2 into this. 2 divided 2. 1 times 1 minus 1. 1 divided 2. 2 times 1 times 1 minus 2. So this is the same thing as minus 3 over 2. This is the same thing as minus 3 over 2. So carry it and put here. Minus 3 over 2. So if you know this now, are you aware that this is the same thing as saying x raised to power minus 3 over 2 is the same thing as saying 1 all over x 3 over 2. This, everything here is the same thing to this. So I now have minus 1 over 2 divided by 1 over x raised to power 3 over 2. Now, are you aware that if this is true, you agree that this is supposed to be? Because if you do this minus 2 now, if you bring it now, minus 1 over 2, if you bring it to times this, because the way it is now, if you bring it to times it, I'm trying to simplify it here. If you bring this thing here, it's the same thing with this. So I now said, if you interpret it, this thing, everything here will go on top of this, which means it's divided. So that is it. So, and this is the same thing as now saying minus 1 over 2 times x 3 over 2 all over 1. So this is the sentence as saying that this is minus x 3 over 2 all over 2. This is our final answer. Let's move to the third example. The third example, I have 2 all over roots x squared. Now this is the sentence as 2 times 1 over root x squared. And this is the sentence as 2 times 1 over x squared raised to power half. This is the sentence. This is the sentence with this. 1 over 2. When something is raised to power 1 over 2, it means square roots. When something is raised to power 1 over 3, it means cube roots. When something is raised to power, for example, 2 1 over 4, it means fourth root. This is the sentence as root 4. That is 2 in fourth roots. So if you know this and this, they are the sentence. So if that is the case, and using indices, you know that this is the sentence as 2 times. Indices, first of all, this thing is the sentence as 2 times 1 all over power rule in indices said that if this is this way, this is the sentence as x2 over 2. x2 over 2. So that this is the sentence as saying x raised to power minus 2 over 2. Now using the L'Hopital rule, we know that to differentiate this is simply going to be the same thing as we are differentiating this. To differentiate this is simply going to be the same thing as saying x, because f of x is where we are focusing on, the things connected to x. So now this is going to be the same thing as saying minus 2 over 2 is the same thing as, this is minus 2 over 2, this is the same thing as this way, this is the same thing as minus 1, then minus 2 over 2 minus 1. So if you do this very well, then times 2. So if you do this very well, this is the same thing as times minus x. Then let's find the LCM. Minus 2 over 2 minus 1 over 1. This should have been 1 over 1, but I just want you not to get confused. So that this becomes the sentence as 2. Now 2 divided by 2 is 1 times this minus 2. Then this is the sentence as 1 divided by 2 is 2 times 1 minus 2. So this is the sentence as minus 4 all over 2. 2 into this 1, 2 into this minus 2. So this is the sentence as, this is, notice it, as when I did 1, it would have been minus 1 minus 1, which is minus 2. So this is the sentence as minus 2. So if you do it, this is 2 times minus x minus 2. Yes, so this is now the sentence as saying 2 times minus x minus 2 is the sentence as saying minus 2x raised to power minus 2. And this is the sentence as minus 2 times 1 over x raised to power 2. So this is now the sentence as 2 all over x raised to power 2. Now, this is it. And let's move to the fourth one. They said 6 all over x cubed dot x squared. Do you know that this is the sentence that is f of x? The f of x is equals to 6 all over this. This is something as 6 times 1 over x cubed dot x half. Do you remember that in this is said when this and this, when you have a variable, the same variable, and they are having powers, just add the powers up. This is the sentence as saying 6 times 1 over x 3 plus 1 over 2. Oh man, damn. So this is the sentence as 6 times 6 times 1 over x cubed plus. So if you do this, is the sentence as saying f of x is equals to 7 over 2. So this is the sentence saying 6 times 1 over x raised to power 7 over 2. Now this is the sentence x times x raised to power minus 7 over 2. Now in this is said that 1 over x is the sentence as x minus 1. So minus x minus 1 times 7 all over 2 is the sentence as this. So f prime x at this junction is the sentence as, carry this minus 7 and put as coefficient, 7 over 2, put as coefficient, then minus 7 all over 2, subtract 1 from the power. So that this is the sentence as saying minus 7 over 2 minus 1 over 1. This is the sentence as 2 as the LCM, 2 into this. So this is the sentence as minus 7 over 2 x minus 9 over 2. Now there's 6 in front. So when you times this, is the sentence as 6 times 7 is going to be 42. 42 over 2 x raised to power minus 9 over 2. 2 into this 1. 2 into this 21. So this is the sentence 21 x raised to power minus 9 over 2. And this is the sentence 21 times 1 over x 9 over 2. If you know this is the sentence 21 over x 9 over 2. So this is my final answer. This is my final answer. And you know that if this is 9 over 2, this can mean the same thing as, okay, if what we got there is 21 all over x 9 over 2, you need to know that if I have, for example, x raised to power 1 over 2 is the same thing as root x. If I have x raised to power 1 over 3 is the same thing as 3 root x. So if I have x raised to power 9 over 2 is the same thing as saying x raised to power 1 over 2 10 times 9. This and this, they are the same thing. These, they are the same thing. So this is the same thing as saying root x raised to power 9. So that this is the same thing as 21 all over root x raised to power 9. So this is my final answer.